Let's begin. Today is September 1st, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 5, 14, 18, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. So criteria card A looks at our first digit, the triangle digit, and will let us know whether that value is an even digit or an odd digit. Criteria card B will look at our 3 digits, triangle, square, and circle, and will let us know which one is the absolute smallest. So should triangle be the smallest, should square be the smallest, or should circle be the smallest? Criteria card C, again, will look at our 3 digits, triangle, square, and circle, but this time it'll add them all up, and the Turing machine will let us know whether the sum is an even quantity or an odd quantity. Criteria card D will look at our first 2 digits, triangle and square, add them up, and compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will look at our 3-digit solution and will let us know whether something about its structure. Specifically, one scenario is that there are no repetitions, meaning that all digits are unique, as in the example 125, or it could have a double number where there is a single digit repeated, as in the example 112, or it could be a triple number where it's a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards. And we're going to start off with an initial proposal of 314. So the first thing I want to test is I want to know a little bit about that triangle digit. So let's go ahead and test criteria card A. Okay, so the Turing machine approves. Notice that I did choose an odd 3. The Turing machine confirms that yes, triangle is an odd digit. So let's go ahead and type that up in our notes. So in section A, we will say that triangle is an odd digit. And since it is odd, that means I can cross out the evens, which are 2 and 4. Let's go ahead and cross out 2 and 4. The next thing I'd like to test is criteria card C. Okay, so this time the Turing machine does not approve. Notice that we are adding all of the digits up. So let's go ahead and add up. 3 plus 1 is 4. 4 plus 4 is 8. 8 is an even quantity, but the Turing machine does not approve of that. So it's letting us know that the sum of the 3 digits needs to be odd. So let's go ahead and type that up in section C. And that again is that triangle plus square plus circle should be an odd quantity. And since the overall sum does need to be odd, let's look back. So we know that triangle's already odd. So the only way to accomplish the overall sum to be odd is there are 2 scenarios. Either square and circle can both be odd, right? The sum of 3 odds is an odd value. But square and circle could also be 2 evens, because in either case, when you add up 2 odds or 2 evens, that sum is an even quantity, but we're going to add to it that triangle odd quantity, and that will basically have the overall sum be odd. Okay, so we're looking at either an all odd solution or an odd even solution. Okay, and so as a final test for this round, let's actually test criteria card E. Okay, so again, the Turing Machine does not approve of my proposal. So I do have 314. That means it has no repetitions, but that is not valid since the Turing Machine does not approve of it. So we're either looking at a double or a triple solution. Now I will say it cannot be a triple number because if you notice, criteria card B lets us know that there is an overall smallest value. And if you have a triple number, well, they're all equal. So that can happen. So I think it's safe to deduce that the solution does have a double number. So let's go ahead and type that up in our notes in section E. And that is that we're going to deduce that the solution has a double number. And what we do know is that since, well, let's see, do we? Yeah, all we know is that there's a double number, so that means square. Well, can we even say square and circle? If we knew that they were even, then yes, absolutely, square and circle would be the two evens. But in the case where they're all odd, I don't think we can draw that same conclusion, because if they're all odd, we don't know which ones are indeed the double number. All we can say is that, well, yeah, we're still under the impression that it could be either all odd or odd, even. Okay, well, that does conclude this round. We did complete our 3 Turing tests. Now we're going to the phase where we'll be talking about how to construct a good second round proposal. So notice that we did not test criteria card B, letting us know which one is the absolute smallest, as well as criteria card D, where we take the triangle and square, add them up, and compare them to 6. And it really comes down now to those 2 criteria cards, because we've already confirmed A, C, and E. And so obviously what we can say about the smallest value is that it can't be the one of the double numbers. That much we can say, but we still don't know if that could be an even quantity or an odd quantity. And of course we do have triangle and square adding up and being compared to 6. So let's see. Well, there are, as far as criteria card D goes, you could have the sum of 6, you could have 2 3s, and have circle be the smallest. Remember, the smallest cannot be part of the pair. But if it were 3 3, then let's see. I guess if you have 2 odds, I think the conclusion is that you have to have all odds. So that would be interesting. We know we can't have 6 with 2 evens because obviously triangle is an odd. So if it's going to be a 6, it would have to be 2 odds, which then would force circle to be the other odd. The question is it a 1-5 combination, and then circle is going to be one or the other? Well, more than likely it's going to be a 1. And if it's 2 3s, it would also have to be a 1. So that's very interesting. Regardless of which 6 it is, circle would be forced to be a 1. So that said, I don't see any way of knowing in the 1-5 combination what triangle or square should be, 1-5 or 5-1. So that's not gonna work out, because I don't know how to order them or how to choose them. It just does inform us that it should be a 1 for circle. So that means 3-3-1 is a pretty viable candidate. Can it be anything else? We do have the smallest value. There's tons of possibilities. It could also be 1-2-2, but I think there's just way too many possibilities where the sum is less than 6, and plenty of possibilities where the sum is greater than 6. So I think I am going to go with that 3-3-1 proposal, and we'll adjust if we have to. So that seems to be the most plausible. So let's go ahead and type that up, 3-3-1. Okay, so the whole premise of that proposal is the sum of the first 2 digits being 6. So let's go ahead and test criteria card D. Okay, so the sum is not 6. Interesting. Okay. So let's see. That was criteria card D. So what we'll do is we'll type it up and say that the sum of triangle and square should either be less than, less than or greater than 6. Okay, so let's see. That does not necessarily imply that triangle and square are also odd, or both odd, or that square is odd, because you could still have 1 and 3 add up to be less than 6, or 3 and 5 be added to be greater than 6. Okay. And, well, we did say that circle is the smallest. Let's see if that's still the case. And so, let's see, that would be criteria card B. Let's go ahead and test B. Okay, so that is also incorrect. So let's see, let's go ahead and type that up, and we'll say that triangle or square is actually the smallest, and circle isn't. So we'll say triangle or square is the smallest. Okay, so since circle is not the smallest, can we actually, yeah, I think we can eliminate circle, 1 for circle, because if the circle were 1, what would triangle or square be as the smallest? I don't think that's going to be possible. Okay, but I don't think we can cross out 5 for either triangle or square. because one or the other could be it. We just don't know which one. Well, this is very interesting. Okay, so let's take a look and see. Remember, we still do have a double number somewhere. So we know at least triangle and square can't be both 1, because even though those are a double number, there's nothing, they're equal. So that much, I think that much we can say. We know that triangle and square cannot be equal, because among them must be the smallest. So we know it can't be 1, 1 or 3, 3 or 5, 5. That much we can say. But what would be the other? So let's start considering. Let's see. Let's go back to the sum of triangle and square and see, can we figure something out? So I guess that the fact that they can't be doubles does reduce the number of sums that are less than or greater than by a bit. So for those that are less than, it would be 1, 2, 1 for triangle, and then it could be 2, 3, or 4 for square. 1 and 5, 1 triangle, 5 square is invalid because that sum is 6. And then 3 could be added to 2 for square, and that would be, well, you could, I guess, also have 3, 1. Oh, that's, let's see, yeah, 3, 1. Yeah, there just seems to be too many possibilities. How can we narrow it down? How can we narrow it down? And so it seems to me that circle, yeah, so since circle is not the smallest, that means it's going to be forced into one of the other values. So, okay, so here we go. So if we look at it from that standpoint, if we say, for instance, it's square and circle that are the double. So that's going to be 2, 2, 3, 3, 4, 4, or 5, 5, which would mean that triangle is the smallest. So you could have something like 1, 2, 2. That sum is less than 6. But so is 1, 3, 3. That sum is less than 6. And so is 1, 4, 4. And 1, 5, 5 is invalid because 1 and 5 do give us 6. So it seems to me that it looks like triangle 1 cannot work because you have too many ambiguous solutions that seem to work for all the cards, all the criteria cards. So yeah, I cannot tell the difference between 1, 2, 2, 1, 3, 3, and 1, 4, 4. They all work for all the cards. So I'm going to go ahead and cross out triangle 1 because that didn't seem to work. Okay. And so what about if square is 1? So that would be our smallest. So then the next possibility would be 3, 1, 3, or and that would be the only possibility, 3, 1, 3, because 5, 1 doesn't work because that sum is 6. So you know what? Let's go ahead and start typing some of these out. So it looks like 3, 1, 3 is a possible solution, square being the smallest. And So would, yeah, okay, so 313 works, they're all odd. Remember, we either have to have two evens. Okay, so let's take a look at that. You could have two evens, and that would be square and circle. So let's do that. Let's actually list those out, because there's probably less of those. So you have 322 and 522. Let's see. Oh, actually 322 and 522 cannot work because remember, it's the non-paired that has to be the smallest. And in those cases, 322 and 522, both 3 and 5 are bigger than the pairs, which cannot happen. So that means that as far as having two evens go, the only possibility is a 344. Because in that case, 3 is smaller than 4. 544, again, would not work because the 5 is greater. The non-pair is greater. You can't have that. Okay, so it looks like the only even pairs solution would be 344, which makes it unique, which is very interesting. Okay, so now let's go with an all odd solution. So let's ignore the evens for square and circle. And so we did start off with 313. I guess you could then go on to 513, where the square is the smallest. I'm sorry, 515. Oh, but 515 wouldn't work because that sum is 6. Okay, wow. And we can't have 332 because that you need all odds. And we know we don't have a triple number. So it could be 355. And how about 535? 535. That also seems to work. Now, might that be the final list? So again, as far as having pairs of evens, the only one that works is 344, because we need a smallest non-pair. And then for odds, 313. I think that's the only one for 3, because again, you do have to have a smaller odd. 313, and then 535. Oh, and also we said, oh, yeah, 515 and 355. Okay, so it looks like the last two have a sum of 8, which is greater than 6. And they both do have a different smallest value. So you can differentiate between those two. But then also 344 has a sum that's greater. Okay. And let's see, so we kind of have two different solutions for each of triangle or square being the smallest. Can we differentiate? Well, let's take a look at triangle first. Is there a difference between 344 and 355? They both have a sum that's greater, and they both have 3 as the smallest, a square. I don't see a difference between 344 and 355. So I think I can cross out 344 and 355. I just don't see the difference based on all the criteria cards. Okay, so now it comes down to square being the smallest. And yeah, it comes down to basically what is the sum of the first two digits. Is it less than or greater than? And I'm wondering, again, sort of gameplay, can we just eliminate 535 because, it also had a sum that was greater than, or is that what differentiates it of the ones that are greater than? It has the square digit be the smallest. There's an argument for that as well. Whereas 313, it checks both boxes, right? Square is the smallest and the sum is smaller. So I don't know, would 313 make one of those cards irrelevant? If I knew the sum was the smallest, does that imply that square is the smallest? If I know the sum is the smallest, or smaller than 6, that is, would that necessarily imply? Yeah, that may imply, right? Because if based on the board right now, what we've crossed out, I would think the only way you can get a sum that's smaller than 6 is if you do go with a 3. And it can't be 322 because it wouldn't be the smallest. So yeah, it almost does short circuit the question of which one's the smallest. Well, I don't think, I think I could deduce that it should be 535, but, I am going to test at least one more question in the third round, since what I really want to test is whether the sum, or whether, I guess I'm testing the sum. That's what's going to differentiate what I do have left. And so, yeah, let's go ahead and, test 535. Even though I feel pretty confident. Oops, I do need to go to a new round, so I'll type in N for new, and there we go. It's prompting me for the new proposal, and I'm saying 535, and I am going to test just the sum of the first two digits, and that would be criteria card D. Okay, so yes, the sum has to be greater than 6. So let me go ahead and cross out the less than and the or. And so yeah, the sum of the first two digits is greater than 6. So were the other two that I crossed out. But of course, those two have triangle as the smallest. And since 313 has a sum that's smaller, let me cross it out. And so yeah, I feel pretty confident that 535 should be the answer. And there's just way too many things to cross out, so I'm just going to type up the solution 535, and let's go ahead and verify that. Okay, so 535. Oops, 535. Now let's see. Okay, fantastic. But how did we do versus a Turing machine? So we did go to a third round, which we haven't done so in quite some time. So we'll see how we did. There were 5 criteria cards. We did 6 tests, but I think this was a slightly more difficult, nuanced puzzle, so anything's possible. So let's do this. So we did A, C, E in the first round, and A was the only correct one. We did the other 2 remaining criteria cards, B and D, in the second round. Those were also incorrect. And then we retested D in the third round and got that correct. So let's go ahead and type that up. So ACE in the first round. So A was correct, C and E were both incorrect. And then B and D were incorrect. And then I don't know, we kind of squandered, or we just, we didn't take our third test, but we couldn't. It would have been irrelevant. And then finally, yeah, we got D correct on the last one. Oh, wow. Oh, look at that. So we did tie the number of questions, but the Turing Machine did it in only 2 rounds. That's the tiebreaker. So even though we tied on the questions, it took me 3 rounds where the Turing Machine took 2 rounds. Okay, so did not get it done, this puzzle. So the tricky part is probably, criteria cards B, C, and E, B, C, D, all have 3 different, possibilities, so less likelihood of luck, in essence. And it was unfortunate that the 2 tests that I needed, where I needed to retest one of them, I did in the second round. Had I done one of them in the first round, that may have led to being able to solve it in 6, but in 2 rounds. So those are always tough to kind of figure out. What are those criteria cards that you might have to, test twice? And obviously you want to spread it out so that you're not sort of hamstrung as I was in the second round. But such is life, and so we'll just have to learn from that. Well, what do you think? Besides that, did you see any other possibilities for improvement? Add your thoughts to the comments. How did you solve it? What did you think of the puzzle? And of course, give it a thumbs up so that the video, so that more people can find this channel. And of course, do hit subscribe so you don't miss out on any future videos. Well, again, this was a fun puzzle, even though we did not beat the Turing Machine. It was a good challenge, and we'll see you next time. Have a great one.